If I just don't start it now, it's going to take forever. That's what will happen, won't it, Mr. Computer? Alright. Just have a swig of water. My name is Andrew Weller, and I'm based out of the Petrosys Perth office. In today's Petrosys video, we're going to see how the Petrosys Task List can speed up your workflows and quickly give you results from repetitive tasks. So the agenda for this video, we're going to look at how we can change variables in the Petrosys Task List. We're going to see how we can automate routine tasks. We're going to see how you can draw maps directly and automatically from workflows, and we're going to see how we can loop over some of those repetitive tasks. This all falls under the umbrella of scripting in Petrosys, and scripting is the ability to control the parameters in a task. What is a parameter? Any piece of information within a task is considered to be a parameter. So for example, if I'm creating a grid, the cell size that I use, the output grid name that I define, the fault file that I use, etc. These are all parameters in my task. How can scripting help you? We have functionality which enables prompts to be launched from within the workflow so that people can interact with it and specify, for example, output file names, input variables, etc. We can make the output of one task automatically flow into the input of another task. So for example, in my task 1, I may grid a two-way time horizon. In my second task, I may grid some velocity. I then want to bring the outputs of both of these tasks and use it as an input into my task 3, which is my depth conversion process. We can also loop over parameters to analyze different scenarios, and we're going to look at that in the demo. And we can also create maps and images automatically and directly from within our workflows. So without further ado, I'm just going to minimize my PowerPoint here and jump into Petrosys. I've jumped into Petrosys Surface Modeling, and it's within Surface Modeling that we can do all of our scripting and looping. I have a pre-canned task here that I have enabled, and it's just simply a grid create grid. If I double click on that, here's my output grid and its associated CRS. Under input data, you'll see as I just scroll down a little that I'm gridding up some average velocity data for the Umarella horizon. Under output geometry, I specify my area of interest as this map sheet, and it's here that I specify the cell size that I use in this gridding process. Under methods, I'm just using standard gridding minimum curvature in this example. The final thing I'd like to show you here is the clipping tab, and I'm choosing to clip this data or clip this grid to the data envelope or the convex hull. So that means that it won't extrapolate past the spatial extents of my data. Now, to look at the parameters that are associated with this task, I click on this icon here. And you'll see I've got a list of lots of different parameters. Things like the output grid, the output CRS. If I just order this by status, you'll see that I have a couple of letter I's here associated in two of these rows. What I've done here is I've highlighted these individual parameters and I've clicked on the Set Interactive button. That then establishes this letter I with those individual parameters, and what I am specifying as interactive in this case is my grid cell size in both X and Y. So I'm just going to cancel and I'm going to run this individual task. Now you'll see the first thing that I'm presented with here is a dialog that asks me to interact with this gridding process. The two interactive parameters that I specified were my cell size in X and Y. So it's here that I can change my cell size if I so desire. But in this case, I'm going to go back to the original 1000 by 1000. And when I click OK, and just OK to overwrite my grid, it jumps in and it creates my grid. Let's have a look at the output in Petrosys mapping. So this is my grid that's displayed on my map sheet. So it's the grid of my velocity data to the Umarella horizon. You'll see that the grid is clipped, and this has been clipped to the spatial extent of my data, so based on that data envelope. You'll also see that there's some noise apparent in this grid, and we're going to look at the effect of smoothing and looping over that variable to see how it changes the effect and the output of my grid. If I jump back into surface modeling, before we look at some smoothing, I've got another pre-canned task here, which looks at parameter migration. So I have my grid create grid, which is exactly the same as the one before. I'm taking that velocity data and I'm creating a grid from it. But you'll see I've got a couple more tasks here. The first one is a tools draw map command. If I double click on that, you'll see what I'm doing is I'm grabbing this template DBM or template map file, and in the background I have scripted this. So I'm taking the output of my grid create grid and using it as an input into my template map file that I have already created in Petrosys mapping. In that process, I can also save a runtime or new DBM map file, and I can choose to save it out as a raster file, as a PDF, or send it to the plotting system. In this case, I'm just saving it out as a raster file PNG, and this is the name of that file. The third task is my tools run command, and this is a very simple one. If I double click to open it, you'll see what it's doing. It's running the command which launches that PNG output file that I've specified in the draw map task. And all this does in my case here is it launches my default application for displaying PNG images. But as I said, I've scripted this in the background. So if I click on the tools draw map and again click on this icon here, let me just arrange the rows of data, you'll see that I've got three S's now associated with these parameters. The first one here is this grid file, and if I just click on edit, what it's doing here is it's taking the output grid for my task ID number 1, and my task ID number 1 just happens to be the output grid file. In fact, what I'll do is I'll just move this down a little so that we can see these tasks in my workflow. So I click on edit and you'll see that it's hooking into the output grid parameter in my task ID number 1. And my task ID number 1 is my grid create grid. Now I don't need to type this in. I can click on this plus button here and it exposes all the parameters through all the tasks that are associated with my particular workflow. So if I click on task ID 1 and I scroll down, I have the output grid file here. The other two components that I am scripting are my outputs from that draw map functionality. So I'm just going to open up this one here, the output image file. And what I've done here is I've hard-coded this component. So rasters, I have a subdirectory called rasters that I would like these images to be saved in. I'm then grabbing the name for my task ID number 1, the output grid parameter. So it's the same name, and I have this replace suffix component, so I'm replacing the GRI of my grid with PNG so that I save out this raster. And again, I don't have to type this in. I can click on this plus button here, and I can go to different functions that are available to me when scripting. So I have this text replace suffix here. I also have things like a timestamp if I want a timestamp for some of the outputs that I may create. This final scripting parameter here is the same as the raster, it's just I'm saving this out as a dbm. So I'm replacing the suffix gri with dbm for the output runtime map file that I will create. Finally, the tools run command, if I click on this icon, it's just a very simple function here with one parameter, and the parameter that I am scripting in this case is the output image file from my task ID 2, which happens to be my drawMap function. So let me run through this task. So again, the first thing I'm presented with is this dialog which asks me to interact with that gridding process, but I'm happy with this cell size, so I'm going to click OK. I just need to OK to overwrite those files. It jumps into the gridding process, it draws my map, it saves it out as a raster, and that run command then launches my default application for viewing images. So you'll see it's the same grid file as before, so it's the same grid file on my map. Let me just show that here. It's the same grid file, so I still have that noise associated with it. I also have a scale bar and a color bar associated with that grid. But the last thing I'd like to do is just see the effect of looping over that smoothing parameter. So I've got another pre-canned task here called looping. Now, I've got those three tasks that are exactly the same as before. I create the grid, draw the map, and launch the raster. But I've now enclosed this with this looping command. And I access that from here. Workflow, loop over highlighted tasks. So if I double click, in Petrosys we can loop over a range, we can loop over a series of files, a series of SDF horizons, or a series of alpha strings that you may have in your file name as an example. In this case I'm looping over a range. I have named that parameter smooth. My start value is 1, my stop value is 3, and my increment is 1. So 1, 2, 3. If I jump into my grid create grid, I have made one small change here. If you see the smoothing tab, I've ticked on smoothing, and I'm smoothing using the Bartlett 7 filter, which is quite a coarse filter. So if I click on this icon here, which exposes those parameters to that grid create grid, and let me just arrange this, you'll see that I've got a couple of scripted parameters in this example. The first one I'm going to look at is this smoothing passes number parameter. And what I'm doing here is I'm hooking into my task ID number 4, which happens to be my loop begin function, and the parameter is smooth. And if you remember, that's the parameter that I named, and it's the counter as it loops through, my 1, 2, 3 counter. I'm also scripting the output grid name, and as before, I've hard-coded this component. I've appended the word smooth, and what I'd like to append to the end of that is the smoothing counter. So again, my task ID 4, which is my loop begin, the parameter smooth, which is my counter, and give it the suffix gri. So I'm just going to run through this task. I just need to OK to overwrite those files. So it jumps in, it creates my grid with a one-pass filter, it draws my map and displays the raster. You'll see it jumps back to the beginning again. This time my counter is 2. It does 2 smoothing passes, creates the grid, draws the map, launches the raster. Finally, it jumps in for a third time. This time my counter is 3, so it iterates 3 times around my smoothing filter, creates the grid, draws the map, displays the raster. And that's all happened in front of us as we've run that workflow. And what you'll see, I've got the same output as before, so I've got my grid, but I can iterate through these, and as I do, hopefully you'll see the difference. It includes my original grid with the noise. It's also got different smoothing passes, so you'll see how my grids change as I iterate through those. You'll see that the name has changed as well, so I've got my smooth underscore 02, 03, and 01. My color bar is also hooked into the grid that I'm displaying, so you should see that change too. And I also have a scale bar associated with it as well. So I'm just going to jump back into my PowerPoint. So some final thoughts. Hopefully I've been able to show you how you can create generic workflows in Petrosys, how we can have those interactive dialogues that pop open so you can specify input or output files or variables that may be a component of that task. Hopefully I've shown you how you can share your workflows with your colleagues and peers, how we migrate output parameters from one task and use them as input parameters in another task. Hopefully I've shown you through looping how you can easily repeat those tasks that you do time and time again by looping over them, and how we can draw maps automatically and directly from within our workflows. So if you'd like some more information, we deliver regular training courses globally, right through from beginner courses, so an introduction to Petrosys, through to more advanced courses such as depth and velocity modeling, geological mapping and modeling, for example. We also have videos, and videos are available on our website and on our YouTube channel. And we also have a social media presence, so Twitter, LinkedIn, Facebook, and of course YouTube. Thank you very much for watching this Petrosys video.